Every object has a life cycle, starting with when we get the material to when we make and move the material to when we use it to when we dispose of it. For example, you could evaluate the life cycle of a solar panel, from extracting the material to the various stages of processing it, making the panel and module, transporting it, using it, and finally disposal. The formal evaluation of this life cycle is a process known as life cycle assessment, LCA. Some people call it life cycle analysis. And this takes analyzes the steps from cradle to grave, from the birth of the thing in raw material extraction to final disposal, cradle to grave. The method for doing life cycle assessment was developed in the 90s by this Society for Environmental Chemistry and Toxicology, CTAC. And when you think about what might be involved in doing an LCA, all the details that you have to dig out and investigate, you come to realize why this is a very complex and time-consuming process, and why it requires specialized training to be done properly. However, you can still do a simplified life cycle assessment for a product or a building that will still help you understand a lot about what you've got there and what the impacts are. And you just do the best you can. You think about the impacts in each stage of the product's life. What happens when the material is extracted? What happens in the processing and manufacturing? Are there issues with use? Where does it go at the end of its life? The grave part of cradle to grave. Every object has inputs, the raw materials and the energy that go into it. It has processes, from processing the stuff to using it to disposing of it and transporting all of that stuff. And then it results in outputs: greenhouse gas, pollution, waste, pollution in the water, pollution in the air, solid waste, and so forth. So you want to think about all that methodically. I'll just quickly go through the steps in a formal life cycle assessment. What you might notice is that these steps are very similar to a building design process, or to a planning process in a company, or to a greenhouse gas inventory process. It's often the same sort of steps, and they begin with defining the scope. What is it you will assess? What are the boundaries? This graph is from Autodesk, actually, looking at the scope. So you can't just go on infinitely big. You have to define a boundary somewhere, and you'll find this when you do greenhouse gas inventories as well. Are you going to limit your scope to the impacts caused by your factory? Or are you going to spread all the way out to the emissions from the airplanes that brought some of your batteries, or to what the customer might do with your thing that you can't control? Where are your boundaries? Then you do an inventory, and in building design you do a site inventory and then a site assessment. Here you do that with LCA, so you take an inventory of all the materials you use, all the energy you use, all the waste you release, and you do that at each stage of the life cycle. Well, you might even be able to do that somewhat informally with a project you're working on. And then you develop a list of categories that are weighted, and what that means is and these are categories of impact from your product. And what weighted means is some impacts might be bigger in importance than others. So you might decide for each number in your chart, some of them are not as important, so you just leave them at their numbers. Some of them might be 5 times as important, so you multiply those numbers times 5, for example. And at the end, you come out with a weighted number. And then you interpret what you discovered in these first 3 steps. You write a final report, and you identify what you can do to improve the life cycle. When we looked at ISO 14000 in an earlier lecture, you might have noticed that part of environmental management is continuous improvement. So when you're doing LCA, you look at continuous improvement. That's the whole point of this, to be able to improve. All these steps are interrelated, and interpretation happens throughout the process. Here's the list of ISO 14000 standards again, and you'll notice that 14040 is an ISO standard for how to do life cycle assessment. And it has a general manual of principles and a guiding framework, and then it has some more details in this 14044. If you're doing a life cycle assessment of a product, you might look at the whole life cycle of the material, the processing, the use, the disposal, and when you're doing your interpretation and implementing, you might look for ways that you could do what they call design for the environment, or DFE. Could you use less toxins? Could you release fewer toxins? Could you use less material? Could you design the object to be reused instead of sent to the landfill, and so forth? When you're designing a building, you can do LCA, and LCA is not required, life cycle assessment is not required for LEED certification. However, you can get credits if you do life cycle assessment under the materials and resources category. LEED really encourages life cycle thinking. And it's more and more common for architects and builders to do what they call life cycle costing. What that means is when you're thinking about what is the cost of this building, and maybe you're working for the owner. So you're not the owner, you're either the contractor or the designer. And you're reporting to the owner, what is their budget? What will this thing cost? They do want to know what are your fees, and they do want to know how much am I going to pay for all these materials that you're using to build the building. But if you do life cycle costing, you report to them how much can they expect to pay over the whole life cycle of their building. And here's an example. If you have very energy intensive lighting and appliances in your building, over the next 20 years or 50 years, your owner is going to pay a lot of money in utility fees. If you have a green building where the building is the system, where they have natural daylighting, passive solar heating, passive cooling, the building is the system, and over the life cycle of the building, their energy bills will be much, much lower. And so you might want to report that to your client. Historically, as we've done life cycle assessment, we have assessed our products and our buildings from cradle to grave. And you're familiar with this cycle now, from extracting the resources through processing, through use, through demolition, and finally through disposal, cradle to grave. What we will look at in the next lecture is a different approach called cradle to cradle, Where there isn't a grave, there isn't a disposal, we keep our materials cycling around and around as much as possible. And I've provided for you a few resources here about life cycle assessment in case you want to go read more about it.